In this clip we'll go through two very important differentiation rules, the rules to differentiate exponential functions, and that's what we're going to start with, and then how to differentiate log functions. We'll start with the rule. If we have a function f of x which is equal to the exponential of x, that can be written in these two ways and graphically represented by this exponential function. You should of course know that it goes through, at x equals 0 it goes through 1, and it always is positive even for negative values of x. So now what we are after is the derivative of this function, and we'll first look graphically at what it should be. We can see that the derivative is always positive. So let's look at this function in three areas: for negative x values, and for x value of 0. And at the x value of 0, the slope of the exponential function is going to be 1. The same as the function value to the left, it's going to be smaller than 1. So the first derivative is going to be in the green area, and to the right it's getting steeper, so the slope will be larger than 1. So it turns out the derivative of the exponential function turns out to be exactly the exponential function again. So f prime x is equal to the exponential of x. Next we are looking at the logarithmic rule. So the rule of how we differentiate a function that contains the logarithm. Here we are talking about the natural logarithm. That's the one which occurs most frequently in economics. So let's first graphically represent the logarithmic function again, because then we get some understanding of what the derivative function should look like. So you may have to remind yourself, but I expect you to know how the logarithmic function looks like. It's only defined for positive x's. At x equals 1, it has the value of 0. It's negative for smaller values and larger for larger than values than x equals 1. So what does the derivative function look like? Again, so here you can see that the slope of the logarithmic function gets flatter and flatter. So we are talking about a declining derivative function here, but the derivative remains positive always. So we are in this green area, but our derivative function is declining. Now at the value x equals to 1, the logarithmic function will have a slope of 1. So it will go, the derivative function will go through this point. At x equals 1, the slope f prime of x is going to be 1. For smaller values of x, so for x value smaller than 1, the slope is larger, and for x values larger than 1, the slope is smaller and yet remains positive. It turns out the derivative function is 1 over x. So the derivative of the log of x is 1 over x. So before we look at an example, we also look at the addition rule. That's quite straightforward, but it's important to remember. If you have a function f of x that really consists of two functions, h of x plus another function of x, g of x, then the derivative f prime of x is going to be h prime of x plus g prime of x. Equally, if you have a function f of x that is h of x minus g of x, f prime of x is going to be h prime of x minus g prime of x. As you can see, I forgot the prime in the minus g prime x, so let's put it in here. Here is a prime. So next what we're going to do is we are going to do a little example so you can practice your newly acquired or refreshed skill. So here we have a function f of x. Let that be 6 times e to the x plus 1 over x squared minus 5 ln of x plus, here we have another term, 7. So the first, it's important to realize that that term 1 over x squared is of course nothing else but x to the negative 2, and everything else is unchanged. So here's the solution. F prime x is the derivation of the first term is just itself, 6 times e to the x, because the derivative of e to the x is e to the x. Second time is second term, negative 2 times x to the negative 3, then minus 5 times, and then 1 over x, because that is the derivative of ln x, and then plus 0, because that's the derivative of the constant 7. We can just come back to this term and rewrite some bits. So the second term will be negative 2 times x to the negative 3, and then negative 5 times x to the negative 1, and then 0. So that's the solution. Here I have a little problem to test yourself. G of z, so that's just like f of x, just another term. And here is a function. And I want you to pause the clip and try it yourself. So here is the derivative. The first term is 4 times 7 times z to the 3 minus 3 times negative 4 z to the negative 5. Just using the addition rule and our standard power rule, then plus 3 times 1 over z, because 1 over z is the derivative of ln z, and then plus 2 times e to the z, because e to the z is the derivative of e to the z. And the rest is just some simplification. 28 times z to the 3 plus 12 times z to the negative 5 plus 3 times z to the negative 1 plus 2 times e to the z.